Okay, so we're starting part B of the video comparing functions. So we should have been actually on part B for example 2. And the question was, if you ride each train for 5 hours, how far will you travel on each? And this really just involves plugging in or extending our table to find out. So if we plug in 5 hours into the equation given, we get 700. So 700 miles would be covered in 5 hours on the Japanese train. And then if we extend the table to go up to 5 hours, adding 217 each time, we would see that we get to 1085, which is actually quite a bit more than the Japanese train. So, you know, as time goes on, that speed really makes a difference on the Chinese train. Okay, so we will be looking at this example, doing it ourselves, and we have a number of new movies a store receives can be represented by the function m equals 7w plus 2. So that's going to be, that's not very pretty, but that's going to be our equation. And then the movie stores, or the store, is also going to be getting games, and the number of games they receive is represented by the table. So what we can see by the table is that each time as a week is going on, 3 new games are added. We're going to want to interpret the equation for how many movies are received. So when it says compare the functions y-intercepts and rates of change, what I've done is I've just copied down the equation and wrote down our formula for slope-intercept form, y equals mx plus b. I know that the b that I'm adding, that constant number, is going to be the y-intercept in this case too. We've just swapped out m and w, or you know, x and y, for variables that make sense for the situation, the number of movies and the number of weeks. So we see that the y-intercept of receiving movies is 2. If we would back up this table to you know, the spot before, we would go down 1 and then down 3 and see that we would get 0, 0. So for the movies, the y-intercept is 0, for the games, the y-intercept is 0. For the movies, the y-intercept is 2. Okay, so that would be part B. The y-intercept for movies is 2, and for games is 0. And then the rates of change. So we could see the rate of change every week. We're adding 3 new games, and in the equation every week we are adding 7 new movies. Okay, so movies increase 7 per month, and games increase 3 per month. Okay. And how many new movies and games will the store have in week 6? So this is going to involve us, you know, doing the same thing we did in the last one, extending the table and then actually using that equation. So if I plugged in 6 weeks for my equation, I would have y, oops, I don't know why I'm saying y, it's m. So m equals 7. Instead of w, I'm going to plug in my week 6 plus 2, and I would see 7 times 6 is 42. Plus 2, 44. So by week 6, they would have 44 movies. If we think about extending the table, we would put 4, 5, 6, adding 3 each time, we would get 12, 15. Having so much trouble with this pen. 15 and 18. Oh, I clicked back too many times. Anyway, that should be a 15 and 18. So we would have 18 new games by the end of 6 weeks. Okay, and last example we're going to go over. I know there are a few more, but this will be the last one I'll be going over in this video. And we have Angela and Benjamin. They have a monthly cell phone bill. Angela's cell phone bill is represented by the function y equals 0.15x plus 49, where x represents the number of minutes and y represents the cost. Benjamin's monthly cost is shown in the graph. So compare the y-intercepts and rates of change. If I look at Angela's monthly bill, her y-intercept is right here, and I could see that on Benjamin's graph, his y-intercept is right here at 60. And so that is actually, not the price per minute because x represents the minute, so this 0.15, 15 cents per minute for her, and we don't know the rate yet for Benjamin, but plus 49, that would be like her flat rate, and then she's being charged for every minute on top of that. His flat rate would be 60, or initial cost. So we could see that Angela's rate of change is 15 cents per minute. That's just coming from the equation right here. And to find out Ben's, we would do just like we had done in that other example, where we're going to use 2 points and use that slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I hope you have that memorized by now. And the 2 points that they used were 0, 60, and 280. 200, 80. Now we actually don't even have to use 2 points right next to each other. When we simplify our slope, we will end up with the same slope as if I had used this point 120, 72. So anyway, we have our y's plugged in on the top, so we have 80 minus 60, and then our x's plugged in on the bottom, 200 minus 0, and they've just gone ahead and divided that to find that it's 0.10, which would be 10 cents per minute. Okay, and then part B, what will be the monthly cost for Angela and Benjamin for 200 minutes? Angela's monthly cost, I would want to plug in 200. So that goes right here into x. 200 times 15 cents plus 49, which will be $79. If we look at the graph to find Benjamin's cost at 200 minutes, and that was actually a point on there, so the minutes right here at 200, he will be paying $80. So, and then, after that, Angela is actually going to start paying more because her rate is more. So after 200 minutes, Ben is still paying a little bit more than Angela, and then it would change after that. Okay, so that concludes part 2 of this video. You are going to be practicing on an Alex